Okay, so let's go through the trial itself, the theme of the H2 physics. This one is the quantum physics. So of course, the very last part is the difficult question. So first part, state what is meant by a photon, right? Okay, so 2 marks. So this one also quite simple, just memorize. So a photon is a discrete packet of your EM radiation, and the energy is directly proportional to its frequency. So that's the very first part. Okay, the second part, we are given this scenario, right, where we have this narrow parallel beam of laser light incident on the surface, right, at an angle of 52 degree. So the next part, they say the beam has a circular cross-sectional area of 1.2 mm. So this is the diameter. So of course, the radius will be 0.6 mm. The laser has a wavelength of 680 nanometer, intensity to be given as such. So the first part, determine the energy of a photon of the laser. This one quite simple, just use E equal to hc over lambda. So we got all the parameters, right? You do the calculation, you should be able to get 2.93 times 10 negative 19 joules. So just take note of one thing, is that this one is one photon. Okay. Okay, the second part, we are asked to show the number of photons incident per unit time, meaning 1 second on the surface, to be given as 1.2 times 10 to the power 16. Okay, first we are given intensity to be 3.1 times 10 to the power 3. So you just relate what is the intensity and the power and the area, right? So you just remember the intensity is equal to power divided by area. So area is pi r square. So of course the area is given to be 1.13 times 10 to the power negative 6. So what you can do, right, is now you can determine what is the power in 1 second. So power in 1 second, you simply just use intensity multiplied by the area. So the power given in 1 second is given as 0.003503 watts. Then you determine what is the total energy in 1 second using the idea of energy equal to power times time, right? So you got power is here, so time is the 1 second. So you do the calculation, right? You should have a total energy in 1 second to be 0.003503 joules. Okay, so with this, you can actually calculate what is the total number of photons, because one photon has an energy of about 2.925 times 10 negative 19. So in 1 second, I have a total energy of 0.003503, right? You just do the division, right? So the total number of photons, right, in 1 second, so you will get something like 1.2 times 10 to the power 16. So it's shown already. So as long as you are able to show, then you'll be given the credit. Okay, so the next part is the 6 marks one. This one is the difficult one. Okay, so for the laser light incident on the surface in figure 6.1, right, we got 2 parts. 55% of the photons are reflected, and the remainder, meaning the 45%, are being absorbed. So we are asked to determine what is the force normal to the surface. It's not the pressure. We are asked to determine the force only that is exerted by the laser light on the surface. Okay, so 2 parts to it. One is the 55%, the other is the 45%. Okay, let's determine the 55% first. 55% are reflected means that, for example, right, okay, so because we are asked to determine the force normal to the surface, means that I need to determine what is the force perpendicular to the surface or normal to the surface. And after that, since you are reflected, means that you get reflected with the same momentum. Okay, so let's do the calculation together. For example, let's do the 55%. Okay, so first we need to determine the momentum. The momentum of the light, right, is P equal to H over lambda. So this 9.75 times 10 negative 28, right, is the momentum in the diagonal direction. Meaning 52 at the 52 degree angle to the normal. Okay, so what we need to do now, right, because it's diagonal, means that I can resolve to the parallel and the perpendicular component. So because I want normal to the surface, means I want this part. So I actually want the adjacent. So this is your adjacent, right? This is your hypotenuse. So since I got the hypotenuse, the momentum to be hypotenuse, right, I can determine the adjacent using the Tuakaso, right? So apparently cosine 52 is equal to a j divided by hypo. So the momentum, so for example, right, if you do the calculation, the momentum in the adjacent direction, right, should be 6 times 10 negative 28. Then what we need to do now, right, is to determine the change in momentum. Okay, what is the change in momentum? For example, right, they say it's reflected, means that you reflect with the same momentum, meaning that the magnitude is the same. So initially, right, the momentum is given to be 6 times 10 to the power negative 28. So you hit the surface, then you get reflected with the exact momentum in terms of magnitude wise, just that of course due to the fact that it's a vector, right, there's a negative component to it. So this thing right here is actually what we call the final momentum. This one is the initial momentum. So what you want to do is actually to minus off. So for example, right, final momentum minus off the initial momentum. So you just get the magnitude wise lah. So you will get 1.2 times 10 negative 27. So this is the change of momentum for just one photon. So since they say 55% is reflected, so the total number of photons that I actually have initially, right, in 1 second is 1.2 times 10 16. So only 55% means that I want to determine how much is 55%. So 55% of this 1.2 times 10 16, right, so it's about 6.6 times 10 to the power 15 photons. So okay, then you calculate what is the total change in momentum for the 55%, right? So you just use 6.6 times 10 15 multiply by the change in momentum, delta P, right, 1.2. Because this 1.2 times 10 negative 27, right, is only for one photon. You need to calculate for the 55%, right? So the total change in momentum for all the 55% is given to be 7.92 times 10 negative 12. So that's the change in momentum. Okay, now the final component already. So the force, remember the force. How to calculate the force? You simply just use delta P divided by delta T. Back to dynamics and your forces. So change in momentum is 7.92 times 10 negative 12 divide by 1 second, because we are only interested in the 1 second, right? So the force exerted by the 55% of the photons, right, is given to be 7.92 times 10 to the power negative 12 Newton. So that is for the 55%. Of course, sad to say that's not the end of story. There's still a 45%, right? Because they say 45% are being absorbed. So 45% being absorbed means that the final momentum will be zero, because you get absorbed. So you will not get reflected. So means that the final momentum is zero. Okay, let's determine the final 45% one. Okay, so 45% being absorbed means that, okay, same thing, right? You can determine the momentum first. So the momentum is being determined actually already, but I'll just do it for the sake of doing it. So the momentum is given as such. Okay, then you determine what is the momentum that is perpendicular to the surface. So meaning that you want the adjacent, because apparently you can see, right, this is your adjacent, this is your hypo. So you just use cosine 52 equal to adj divided by hypo. So the momentum, initial momentum perpendicular to the surface is given to be 6 times 10 negative 28. So that's the initial momentum. Okay, then you determine the change in momentum, because apparently you can see, for example, I draw the metal surface. So the initial momentum is given to be 6 times 10 negative 28. Okay, then after that, of course, they say it's being absorbed, means that the final momentum 0. Okay, then you determine the delta P first using the modulus, right? Just get the magnitude. So simply just use 0 minus away 6 times 10 to the power negative 28. So the change in momentum is given to be 6 times 10 negative 28. Then after that, right, you determine what is the 45%, because only 45% is being absorbed. So the total number of photons initially is 1.2 times 10 16. You determine 45% should give you 5.4 times 10 15 to the power 15. So means that this is the number of photons absorbed. Okay, then you determine what is the total change in momentum, because apparently this one is the change in momentum for only one photon. So I want to determine, what is the total change in the momentum, right, for all the 45% of the photons. So you simply just multiply, should give you 3.24 times 10 to the power negative 12. So that is the total change in momentum for all the 45% of the photons. Okay, the next thing, okay, almost ready. You determine the force. The force by this 45%, right? So just use delta P divided by delta T. So this will give you 3.24 times 10 negative 12 Newton. So this is the 45% of the photons, the force exerted by the 45% of the photons. Okay, the final part to it, So almost already. So the total force that all the photons exert, right, should be, for example, okay, this is the 45% one, 3.24 times 10 negative 12. Then the second part is the 7.92, right? So this is your 55%, this is your 45%. So you add up, right, should give you a total force to be 1.12 times 10 negative 11 Newton. So that is how we actually do the 6 marks question.